Okay, Assalamualaikum warahmatullahi wabarakatuh. So for today's video, before we start for the discussion, so I would like all of you to subscribe my channel and like this video. Okay, if you feel this video very helpful for you. Okay, so in this video, I will show the calculation involving Avogadro's number and Molar mass. Okay, we look at the first question, how to answer this question. If I have 1 mole of HCl, so how many number of HCl molecules I have? So how to do the calculation? First, you need to know that um, if you want to relate mole with number of molecules, so the Avogadro constant that you use here is the Avogadro number. So the Avogadro number. We will use Avogadro number. So in the Avogadro number, we know that 1 mole of any particles is equals to 6.02 exponent 23 particles. Okay. So, for this question, number of HCl is equals to 1 mole of HCl times with, okay, look at this statement here. For the Avogadro, 1 mole is equal to 6.02 10 to the power of 23 particles. Means that for 1 mole of HCl, so we want the number of particles. So we put number of particles at the above of the equation particles. For right now, the particle is molecule of HCl. Okay, divide by 1 mole. Okay, because of we want to cancel the unit of mole, so we put the mole at the bottom. So we can cancel the unit of mole, so we will get the unit of molecule. So we know that the number of molecule is 6.02 exponent 23 molecules. Okay, that is your answer. So how about the second question? How many hydrogen atoms? So to calculate the number of hydrogen atoms, we must look at the in the formula, in the molecular formula, HCl. So one HCl contain one hydrogen. So the ratio here is 1:1. Means that for the number of hydrogen, we should write 1 mole HCl times, okay, we need to calculate the mole of hydrogen first. Calculate the mole of hydrogen first. So we know that 1 mole hydrogen should be at the above and 1 mole HCl at the bottom, because we want to cancel the unit mole HCl. So kita boleh cancel HCl, so kita akan dapat mole hydrogen. So we know that 1 mole of any particle contains 6.02 exponent 23 particles. So we want to know the number of particles, so it will be times with 6.02 10 to the power of 23 hydrogen atoms divided by 1 mole hydrogen. So we can cancel the unit mole of hydrogen. So kita akan dapat tinggal ni je kan. Kita akan dapat 6.02 exponent 10 to the power of 23 atoms. Okay. We do it one by one. First, we calculate the mole of hydrogen. This one. Okay, we calculate the mole of hydrogen, and this is the second step. We calculate the number of atoms. Okay, how about chlorine atom? It is same. Okay, for chlorine atom, so in this molecule, it also has 1 more HCl. It contains 1 hydrogen, and it also has 1 chlorine. The ratio here is 1:1:1. So same as hydrogen. So number of chlorine. Okay, first we calculate the mole of chlorine. So 1 mole HCl is equals to, so HCl is 1. Kita nak cancel HCl, so 1 mole HCl, we write 1 mole HCl. And then this one, we have 1 mole chlorine. So we can cancel the mole of HCl. So we have calculate the mole of chlorine. So right now from chlorine, we determine the number of atoms. So for the number of atoms, we want to cancel the mole of chlorine, the unit mole of chlorine. So 1 mole of chlorine. Okay, 1 mole of chlorine. Atas dia ada 6.02 10 to the power of 23 atoms. So the answer is, so we can cancel 1 mole of chlorine. So the answer is 6.02 exponent 23 atoms. Okay, that is number of HCl, number of hydrogen, and number of chlorine. So how about the second question? Okay, we look at the second example. We have 0.5 mole CO2. So how many CO2 molecules, carbon atoms, and oxygen atoms in CO2 molecule? So how to calculate this one? Same as first example, we need to determine which Avogadro constant that we will use. So for this one, we want to calculate the number of particles. So of course, we will use Avogadro number. So same as the first example, we know that in Avogadro number, 1 mole of any particles is equals to 6.02 exponent 23 particles. So right now we have 0.5 CO2. So how to calculate the number of CO2 molecules? Same as what we do for HCl earlier. So number of CO2 molecules. Okay, number of CO2 molecule is equals to, so we want, what we have here is 0.5 mole CO2. So we want to cancel the unit of mole. So we write 1 mole CO2. And then we want to retain the unit of particles. So right now the particles is molecule. So we will write molecule 6.02 10 to the power of 23 molecules. Okay, so we can cancel the unit mole. So for the answer, we just multiply 0.5 with 6.02 exponent 23. So the answer is 3.01 exponent 23. The unit is molecules. Okay, so this is the answer. Okay, how about the second question, number of carbon atoms. So same as what we do to HCl. So we need to determine how many carbon atoms in CO2. So in one CO2, there is one carbon atoms. So means that the ratio is 1 to 1. So to determine the number of carbon, we need to know the mole first. So 0.5 mole CO2 times. Okay, so we want to cancel the CO2. So we write this first. 1 mole CO2 is equivalent with 1 mole carbon. So 1 mole carbon. So we can cancel the unit mole CO2. So right now we have determined, we have get the mole of carbon. So from mole of carbon, we will convert using Avogadro number. So right now, I want to cancel the unit 1 mole carbon. So 1 mole carbon, 1 mole of any particle here. Remember this Avogadro formula is equivalent with 6.02 10 to the power of 23. So the particle here is carbon. So is it molecule of atoms? Is it atoms? Okay. So we can cancel the unit of mole carbon and leave the unit of atom. So what we get here, same, 0.5 times with 6.02 exponent 23. So the unit is the answer is 3.01 exponent 23 more atoms because this is carbon. Okay, that is question 2. How about question 3? Number of oxygen atoms. So we need to determine how many oxygen atoms in CO2. So from the formula, we know that one CO2 contains 2 oxygens. So what would we do? So number of, I write here, number of oxygen is equals to, so we calculate the mole first. So we have 0.5 mole CO2. So we want to cancel the unit CO2. So we write this one first. 1 mole CO2. And then later we write 2 mole O. So we can cancel unit of CO2. So leave the unit of mole oxygen. So and then from mole of oxygen, okay, we relate it with the Avogadro number using this statement. So we want to want to cancel the unit of mole. So we have 1 mole oxygen. The consists of 6.02 exponent 23 atoms. Okay. So we can cancel the unit of mole oxygen. So leave the unit of atoms here. So the answer is 6.02 times 10 to the power of 23 atoms. Okay. Okay, how about example 3? You have 1 mole aluminium oxide, Al2O3. Okay, so I ask you to calculate number of Al2O3 compounds and number of aluminium ions and number of oxygen ion, oxide ion, sorry. Okay, so for this one, same as just now, it asks us about the number of particles. So what would we do is to relate it with Avogadro's number. So Avogadro's number, we write it first so that we don't forget. So 1 mole particles is equivalent with 6.02 exponent 23 particles. Okay, so right now for the first question, we want to calculate how many Al2O3 compound given 1 mole of Al2O3. So number of Al2O3, okay, is equals to, okay, we have given 1 mole Al2O3, okay, our compound. So we want to cancel the unit of mole, so we write the 1 mole Al2O3 at the above, and 6.02 10 to the power of 23 molecule. So because this is a molecule at the above, so 1 mole 2 at the bottom. Okay, sorry. So we can cancel the unit of it, leave the answer as 6.02 exponent 23 molecules. Okay, that is the answer for the first question. How about second question? It asks us about the number of aluminium ion. So in the formula, 1 aluminium oxide contain 2 aluminium ion. Is it correct? Okay, it is written here. Okay, 2 aluminium ion means that to get the number of aluminium ion, we need to calculate the number of mole of aluminium first. So number of aluminium ions is equals to, so given mole Al2O3, so we want to cancel the Al2O3, so we write this one first, 1 more Al2O3, so and then we write 2 more aluminium 3 plus at the above, so we can cancel the unit of mole Al2O3. So right now we have get the mole of aluminium ion. So after that, we relate the mole with the Avogadro number. So right now we want to cancel the unit of mole. Okay, the unit of mole. So we write the 1 mole. Right now the particles is aluminium ion. So we write the aluminium ion. So we can cancel the unit of mole aluminium ion times with atas tu kita letak 6.02 exponent 23 what? Ions. Okay, this is the ion. So the particle here is ions. So we can cancel the unit. So we get 2 times 6.02 exponent 23, 1.204 10 to the power of 24 ions. Okay, for the last question, number of oxide ion. So same as aluminium ion, we need to determine how many oxygen exist in aluminium oxide. So for this one, 1 aluminium oxide contain 3 oxide ion. So how do we know? We look at this formula. Okay, 3 oxide ion. So given to us 1 more aluminium oxide. So we need to cancel the unit of aluminium. So 1 mole aluminium here we write at the bottom, and then the mole of oxygen we write at the above. So the oxygen has 3 mole oxide ion. So we can cancel the mole of aluminium oxide. Then after that we can calculate the number of particles. So we want to get the number of particles, means that the number of mole of particles mesti di bawah lah. So kita tulislah 1 mole oxide ion. Atas tu kita tulis 6.02 exponent 23 ion. So the particle right now is ion. So remember, we have 3 types of particles, either atoms, molecules or ion. So you need to determine which one is, okay? So we cancel the mole of oxide. Okay, so right now 3 times 6.02 exponent 23. So exponent 23, so you will get 1.806 exponent 24. What is the unit? Ions. Okay. Okay, that is the third example. Okay, how about the fourth example? So it asks us to calculate the mass of 0.15 mole of sodium sulfate. Okay, right now it asks us to relate mole with mass. So the Avogadro constant that we will use here is the molar mass. Okay, so we know that 1 mole of sodium sulfate has mass of, kita kira lah mass dia berapa, 3 darab 2 tambah 32 tambah 4 darab 16, 64. So 142 mass of sodium sulfate is equals to, so given the mole is 0.150 mole of what? Sodium sulfate. Okay, times with, okay. So kita nak cancel unit of mole, so 1 mole is written at the bottom and 142. So kita boleh cancel mole sodium sulfate. So leave us the unit of gram. Okay, so the answer is 21.3 grams. So this is your answer. So for the exercise, so I want all of you to answer this question. I have give you the final answer. So what you should do is to just do a calculation and get the final answer. So for the first question, 1A, calculate the mass of 0.25 mole of aluminium. B, 1.25 exponent negative 3 mole of iron. I have give the relative atomic mass of iron, 55.8. For the aluminium and the rest that I haven't give you the relative atomic mass, you may refer to the list of relative atomic mass that I have give you earlier. Okay, C 0.15 mole calcium, 653 mole neon, E 4.24 mole of gold, F 15.6 mole of helium, G 0.063 mole of platinum, H 6.63 exponent negative 4 mole of plutonium. So that is the first exercise. For the second exercise, I want you to calculate the amount in mole represented by each of the following. Okay, for A, I have copper, lithium, americium, aluminium, sodium, tin, platinum, and iridium. So I've already give you the final answer. So make sure that you do calculation and just I have teach you before to get the final answer. So I think that's all of my video. That's all. So I think that that is for my video. So hope that this video help you to answer all of this exercise. So Assalamualaikum warahmatullahi wabarakatuh.